This is group number 19, and for our project, we decided to make an NBA generator that generates the best players per position per team historically in the NBA. So when you run our program, you're brought to this selection screen where the user can choose either max heap or splay tree, which were our two data structures for this project. So if they choose, say, max heap, they're brought to this menu screen where there's 15 West teams and 15 East teams to choose from. So say they choose Golden State Warriors, they are brought to this data screen where they can see all five player names and all five positions. These are just the best players of all time in their respective positions. If they go back and choose Los Angeles Clippers, they also have this data in the same format, or Los Angeles Lakers, or Cleveland Cavaliers. And if they want to go back and change the data structure to display tree, they can do that and click on the same teams and get the same data. And that's the end of the demo.
Okay, and now we'll go deeper into how we were able to come up with all this data. So for example, look at Los Angeles Lakers, how we were able to come up with all this name. So first of all, we do have a struct of player in which we store all their details, such as like name, team, and all the statistics that we need. We have a function called load players in which we would basically load a CSV file, as you can see player per game.csv right here, and to get all the statistics into that player object. And then we also call a function called compute grade. So for different positions, such as like point guard, then we have like different criteria that we use to validate a player. For example, in point guard, we validate the assist and the point rather than in center, we validate the rebounds and the blocks. Going to the implementation of mass heap, we do have, well, the way I construct the mass heap is the same way with how we do with the traditional massive, which is like we have all these functions like five parents, five right, left child, heap it up, heap it down, and then the thing that I do care about is the insert function, and that I will like insert all the players into my heap, and then I have the pick, in which I would call it to get the best players in my heap. So another function I want to introduce is the function to build different teams. In this function, basically, after we load all the players from the CSV file, I would push all of them into a map to keep track of all of their statistics per their career. By that, I mean that I would divide their whole stat by the season to get the most accurate of their performance over the whole career. I would also keep track of the position that they most frequently play in throughout the whole career. And then I call compute grade to get the final grade. For heap, I create five different heap, each for different position. I will push them accordingly of their position into the corresponding heap, and then I call pick to get the best player per position. So that is my implementation for mass heap.
And now I'll be talking about display trees. The display tree at its core is a BST, so most of the logic stems from that. The tree is comprised of nodes, which each hold a player object and is sorted using player grade. What makes a display tree special is that it displays. It's a series of rotations that bring a node to the root. So as you can see, I have the zig, zigzag, and zig functions that handle the rotations, as well as a display function that calls them appropriately. Like I said earlier, a display tree is a BST, so the logic for insert and search is the same for it. The important part is that after we insert or find the node, we call the display function to bring it up. So I can see after I call insert helper, after we get the result, I display it up. Same thing for search. After we find it, we display it up. The last two functions are how we build the team. Find highest grade returns the player with the highest grade. For display tree, we know that the higher nodes will be on the right, which means we can use the while loop to return the rightmost node. So I can see we keep going to the right until we hit a node pointer and then return that node. The get team function is very similar to the build different team function for max heap. The only difference being that we insert the players into five different display trees instead of five heaps. After they're into the tree, we can call highest grade and find the top player for each position. The max heap by nature has the best player position already located at the root because of heap buying up. This means you can call peak to get the player at the top who will have the highest grade. On the other hand, the display tree needs to search all the way to the right to find the player. This makes the max heap faster at building the teams. Thank you, and that's it for our project.